Hello everybody and welcome to another Patreon selected tutorial topic. This time it's going to be wall jumps with momentum. So if you've seen a wall jump tutorial before, even one of my own, it's probably shown you how to do wall jumps where you check if you're touching a wall and you press jump, give you a jump, just in the same way as we jump from the ground, and maybe even give you a bit of a jump in the direction opposite the wall, okay, which allows you to sort of push off the wall and do cool things like this and jump up the wall. The problem with a lot of those tutorials, including my own, is they don't tend to cover actually preserving some of the momentum you gain when you push off of the wall. And so if you've got like a fixed speed movement system, or you don't have a lot of or you have a lot of air friction or that kind of thing, or your variables for movement aren't set up exactly right, you'll be able to just climb a singular wall. So I'd be able to just like jump on the surface and just sort of climb up the wall just by mashing jump, okay? A lot of people refer to that as being like a wall climbing system rather than a true wall jumping thing. So we're going to do wall jumping today, okay? And it's going to maintain your momentum. So you can see I'm holding right, just have to believe me that I am when I'm jumping off this wall, and you can see I can't just climb up the wall, because when I return to the wall, I get pushed too far away to just sort of climb all the way up the wall, okay? Whereas I can do this kind of thing, okay, and climb that way, which is typically more the kind of thing you might want if you're doing a classic wall jump situation. So we're going to do that, and we're going to add some cool stuff like some dust particles that come off the wall like that, and also just make it give you this cute little animation. So you're pointing, you got this little sliding thing going on, and we'll also make it so it slows you down a bit, okay? So you can see we actually fall a bit slow when we're on the wall, and we speed up a bit when we're not on the wall, okay? Just a simple little flourish just to make it feel a bit better. Simple stuff, let's get to it. So this is the game we're going to be starting with, okay? It's a very simple platformer, object-based collisions. You can jump up and down, can't do any wall jumping stuff yet. That's what we're going to put in. The only difference between this and, say, the platformer I taught in the Complete Platformer series and a lot of other tutorials by a lot of other people on how to make platformers and stuff, is that we move with acceleration left and right, okay? Rather than just setting a fixed speed left and right. We like increase our speed by an amount every single frame we're holding the button up to a given maximum, in the exact same way that gravity works, okay? When you jump, we add a value to your downwards sort of y momentum every single frame, and we just apply that to left and right. The reason I've done that instead of using fixed speed for that, for this particular tutorial, is it'll just make our wall jump feel a bit better, okay? Because otherwise, if you're moving at fixed speed, imagine if you jumped at a fixed speed, you'd go like up a fixed amount, stop, and then move down a fixed amount, and it would look really jagged. The same would be true of a wall jump, so you'd move away, and then you just like drop like that, and it would be a bit pants. So we want a nice smooth arc, and that's why we're using acceleration. You'll see a bit of how that code works, and we'll just take a look at it in a second, but I'm not going to go into it in a huge amount of detail. I'm just telling you that's how it works in this, if you want it to be nice and smooth. So this is our player's code as it currently stands, okay, basic variable setup, and in the step event, I'm just going to walk through very quickly how this works, just to give you the context. There's stuff you might already be aware of. If you're not, don't worry too much. But just to give you an understanding of how, or possibly just a reminder of how the player code flows, because we're going to do a lot of modifications to this to get everything working just right, and I want you to understand where everything is going and why. So at the beginning, we've got the input collection, different keys, check which buttons we're pressing, and then based on that, we calculate which direction we want to accelerate in horizontally if we're pressing left or right, okay? So rather than just setting HSP to equal the result of key right minus key left, we're approaching a certain value based on our acceleration and friction, based on if we're on the ground and in the air. Okay, just some simple stuff just makes that a little bit more complicated. Don't worry too much if you, as I say, if you don't know how to do that. But that's how we're doing it. Calculating vertical movement is very straightforward. It's just gravity, VSB plus equal grav. And ground jump if we're on the ground, or if we've only just left the ground. We've got a little jump buffer working here, okay, so we can leave the ground and wait a few frames, then press jump and it'll still work. Dumping our fractions and moving it only at integer speeds, that's always very important, very, very useful to make sure your x and y are always at whole integers and never at decimals, because that can cause weird problems for rounding when you're colliding, checking subpixels, which you don't want to do. We do our collisions, horizontal first, and then we move horizontally, then vertical, and then we move vertically, okay? Then afterwards, we check to see whether or not we're on the ground. which is useful for all kinds of things, but doing it here is nice to do it as a result of all your movement, and then we adjust our sprite accordingly, so our sprite is definitely up to date with everything that's gone on here. Okay, and we check if we're on the ground or if we're not, and do our air sprite and our ground and running sprite. Okay, so that's how our player works. Again, if you don't understand any of that, or if some of it is different from my other tutorials that you followed or other people's tutorials you followed, don't worry too much. Just try and understand the general flow of how this player is working. Okay, so with all that cleared up, how do we go about adding all of our wall jump stuff? Well, there's a few things we want to do to accomplish everything we want to accomplish, okay? We want to first of all find out if we're on the wall. That's the key part, okay? Then we want to adjust our sprite accordingly, so we've got a little animation for when we're sliding down the wall. We want to change gravity, so we slide down the wall slower than we would regularly fall. We want to allow you to jump off the wall, so if you are on the wall, give you a jump. And then once we've done that, we want to then add some momentum, and we'll come to that at the end. So the first thing we want to do is check to see if we're actually on the wall. It's the biggest key to this whole thing, and it's actually also the simplest part, madly enough. I'm just going to scroll down to the bottom of our player's step event, where we've got calculate current status, and we're working out if we're on the ground. We're going to do something very, very similar to work out if we're on the wall. Okay, I'm going to type on wall equals place meeting x plus 1 y o wall. Okay, so rather than checking 1 pixel below the player by checking y plus 1, we're going to check 1 pixel to the right of the player, okay, with x plus 1 on place meeting. But then how do we know if we're colliding? We know if we're colliding with a wall on the right. What about a wall on the left? Well, what we can do is do something very similar to what we did with key right and key left to determine which direction we want to walk, if you're familiar with the platformer tutorial, which is to write place meeting x plus 1 y o wall minus place meeting x minus 1 y o wall. So this is going to return true or false, or rather 0 and 1, depending on whether or not there is a wall to the right of us, and this will return 0 or 1, depending on whether or not there is a wall to the left of us. So if you imagine if there was a wall to the left of us, what we're going to end up with 0 minus 1 minus 1, okay? Or if there is a wall to the right of us, we'll end up with 1 minus 0, so 1, okay? The only weird spot of this is you won't be allowed to wall jump if you have a wall perfectly left and perfectly right of you. But if that was the case, I don't have a specific sprite for like touching both walls anyway, okay? So I'm going to leave it at that. And the hitbox of the player in my specific case here is smaller than the gap would be between two walls, at least placed on the grid, so it doesn't matter too much, okay? All you need to know is this line is going to return minus 1 if there is a wall to the left of us, and positive 1 if there is a wall to the right of us, which is very helpful because then just by checking this, we know not only whether or not we're on a wall, but we also know which side the wall is on just from this one variable, okay, which is very, very useful to us. Of course, the other thing we want to do, having just written in a new variable here, is also establish this in the create event, so go ahead and add that. I've set on ground to be false because that is an actual boolean. It's between 0 and 1, right? So it's good practice to actually use false. This isn't a boolean though, it's going to be minus 1 or 0 if there is no wall either way, okay? So set it to 0, not false. So now we know whether or not we're on a wall. The next thing we're going to do is adjust our sprite appropriately and maybe kick up a bit of dust while we're sliding down the wall, okay? So first thing I'm going to do is add dust equals 0 to our pile of variables, okay? It's going to be a useful variable. It's going to be counting up to decide whether or not to let off a dust particle. Okay, so in the step event, down here where it says adjust sprite, this is where we determine if we're on the ground. If we're not on the ground, rather, we set our air sprite and set the frame accordingly. And if we are on the ground, then we set our sprite accordingly. So our wall jump frames, we're only going to want to use them if we're not on the ground. Okay, so it's going to be in this section. And if we're in this section and we're on a wall, then we want to use our wall jump sprite and overwrite these. So we know what we can do. Inside here, we're going to write another if statement, which is if on wall does not equal 0. Okay, so note that that is not if on wall is true, or if on wall by itself, or if on wall equals 1, because it can be 1 or -1 to tell us that we're on a wall. Okay, so we need to check that it's specifically not 0. If that's true, then in here we want to override our sprite with our on wall sprite. If it's not true, if we're not on a wall, then we want to use our regular in-air sprite, because we still know that we're not on the ground. Okay, so let's put that stuff in here. Oh, and also in this else, it'll become clear why in a minute. I'm going to write dust equal 0 in there. Okay, so if we're in here, we're going to set sprite underscore index to equal s player underscore wall. That's just what I happen to have named mine. If you've got one like this, you can name it. If you don't have a sprite for your wall jump, then you don't need to do any of this, so don't worry about it, but this is how we do it if you need to. Okay, image underscore x scale equal on wall. That's very useful, because if we're on the right, because it's 1 and -1, if there's a wall on the right, then we want our image x scale to be 1, which is facing to the right. You can see from our sprite, he's facing to a right wall. And if it's -1, we want to flip the image x scale to be -1. Okay, make sure you've got all your origins and hitboxes and everything set up correctly for how you want to do it, so you don't flip into the wall. If you find yourself getting stuck in walls after doing this, this line is probably what you want to look into. It's probably to do with your origins and your hitboxes. Okay, so be very careful about that. Okay, and before we do anything else, let's just see that that works. Okay, so I'm just going to quickly run the game. We should find now, we run and jump on the wall, you can see he's already doing the cool little slide animation. Okay, really is as simple as that. The next thing I'm going to do is make that dust appear. I know it's a bit superfluous, so feel free to skip ahead in this part if you just want to get to the whole wall jumping thing. We are adding a few little fancy things before actually doing that, so feel free to skip ahead. I'll put a time thingy on the screen. But for the dust, I'm going to write var side equals bbox underscore left, and if on wall equals 1, side equal bbox right. Okay, so bbox left and bbox right are the left and right, respectively, x coordinates of our player's hitbox. Okay, so that's going to be like here, or like when it's flipped the other way, it'll be here. Okay. So the reason we want that is because we want to. That's where we want to create the dust. Okay, we're going to create it in the sort of the top right of the player, so it's coming from like sort of the top of his hand over here. Okay, or as close as we can to that. So once we've worked out that variable, I'm going to type dust plus plus, which is going to add 1 to the dust variable. Okay, and then if dust, actually if open 2 brackets, if dust greater than 2, close 1 bracket, and VSP greater than 0, close all the brackets. Okay, so wrap that in those two. So if dust, if we've added to dust a couple of times and it's reached 2, so it'll do this once every 3 frames that we're on the wall, and we are moving downwards. Okay, we're just going to have the dust come as we're sliding down rather than as we're like sliding up at the same time, just to create a consistent effect and it's clear when it's happening. Okay, so if that's true, then we want to say with instance create layer. Where we want to create its x coordinate is side, so either bbox left or bbox right, depending. Bbox top, which gives us the top of the player, so it's coming from, as I say, just from about where his hand is. The layer is behind. That's just a layer I've added for where you can put whatever layer wherever you want to create your dust. Oh, dust. Okay, and that's a special object I've made that's very, very simple. Before we carry this on, let's just take a look at this object. Simple gray sprite that just like sort of fades into nothingness. Its create event gives it some vertical speed, and we give it a bit of a random image speed, so it animates at a random pace, and then when its animation ends, we just destroy it. Okay, very, very simple way to create a very basic particle. Okay, let's just create a really short, simple animation, randomize its behavior just a tiny little bit, and then just create them. And that's a really simple way to create particles without having to go through the whole particle engine stuff. Okay, so back to our code. So if that, then with this, we've tapped a with statement because we want to actually do some stuff with it. So open a pair of curly brackets, which will determine what we're doing to this dust. So inside that dust object, I'm going to type, first of all, I'm going to set dust in the original object to 0. So I'm going to type other.dust equals 0. This is a bit backwards because we've gone inside the object to set a property of the previous object, which might not be the best practice, but it's the simplest way to do it with the least amount of code, okay? So other dust back to 0, so that we do this once every 3 frames, and hspeed, this is of the dust particle this time, equals other.onWall times 0.5. In fact, sorry, negative other.onWall times 0.5, okay? So that's going to give us a horizontal speed for the dust opposite of the direction of the wall that we're on. So when we're sliding on a wall to the right of us, it'll give us like negative 0.5. And if we're sliding on the wall to the left, it'll give us positive 0.5. So the dust will come away from the wall, okay? Very, very simple. And I believe now, and dust gets set to 0 if we're not on the wall, okay? Which we set earlier. So let's just run that, and I can just show you that all happening now. Yeah, we got our dust coming off the wall. Once every 3 frames, okay? So now we're at the point you all actually came here for. Welcome back, those of you who skipped ahead. As I say, no problem with doing that. But we've added some cool dust effects, so if you want to learn how to do that, you can go back and watch those bits. What we're going to do now is actually allow the wall jump to happen, and change our gravity as well, so that we slide down the wall at a slower pace than we would regularly fall, okay? The first thing I'm going to do, though, is go into the create event and add a few new variables that we're going to need for this, okay? So gravity, we're going to have another kind of gravity. So we're going to have grav, which is our just general normal gravity, and grav underscore wall, which is going to be 0.1, okay? So just a slightly different, slightly lower gravity, just enough so that we can kind of notice it. HSP is going to get a new variable called horizontal speed W jump, which is going to equal 4. Okay, I know it's the same as walk, so we could have used that, but if we want to make them different, and this is a variable you're probably going to want to tune a lot and control, so it is worth making a variable for it. And that's going to be the speed at which we jump away from the wall horizontally. Similarly, we want a VSP W jump, which is our wall jump away from the wall, which I'm going to set to -5. We don't want to jump quite as high as we can from the ground, and you'll see why for in a minute. I've tuned these values a little bit already, so they already work, but you'll probably want to play with these to get them right for your own game. You'll see, you'll want to see them working first before you tune them, but you'll see why. And also under here, we've got a VSP max, which is our maximum falling speed, so our gravity doesn't just make us fall like faster and faster forever, but we also want to reduce that when we're on the wall. So because otherwise, we've reduced the acceleration with our gravity change, but we haven't reduced the actual terminal speed, which you would do if you've got some heavier friction on here. So I'm going to say VSP equal max underscore wall equal 4 instead. So, okay, that's less than half of our max speed when we're falling. All right. Once you've added those variables in, let's come back to the step event on this. So let's go, first of all, right up to the top and find where we calculate all of our horizontal movement, okay? So however you do this, however you calculate your horizontal movement, when you're determining whether you're moving left and right, underneath that, and before you start dealing with your vertical stuff, we want to work out our wall jump stuff. So I'm going to type wall jump as a comment here, and then if on wall, that's our thing that tells us whether or not we're on the wall, -1 or 1, does not equal 0. And we're not on the ground. And key jump. Okay, so very simple logic here. It's just if we're either on a wall to the right or we're on a wall to the left, because it's not 0, and if we're not on the ground and we've pressed jump. Those are the circumstances in which we want a wall jump to happen, okay? So in here we're going to type HSP equals negative on wall multiplied by HSP W jump. Okay, so obviously if we want to roll to the right, we want to jump to the left, so we want to move negatively. So we turn our what will be a 1 into -1 and times that by our W jump of 4, so we get -4. If we want to roll to the left, then it's -1, it's -1, which becomes 1 times 4, 4, okay? and VSP equals VSP underscore W jump. Okay, which will make us jump vertically a little bit, okay? Then I want to set, if you've got this system going on where you're dumping fractions and getting final integer speeds, you have to be careful when you set a speed to something. Like when I jump, I set my speed to be vertical speed jump. I also then have to set my fractional speed to be 0. Otherwise, you might still have some fractional speed left when you're moving down because of gravity, and that might then later influence how high your jump is ever able to actually get, and you might end up with sort of inconsistent jump heights. If you don't understand what I mean or what I'm talking about at this point, and you're like, VSP frac, I never added that in any of your previous tutorial, what is any of that to do with? Don't worry about it, okay? If you are using the system, and then you know what I'm talking about, and you just need to remember when you set a speed, so you're setting a speed from VSP to 0 to something else, make sure you clear what's in your fraction as well, otherwise you'll get inconsistencies. If you don't know what this is and you don't know anything about it, then you don't need to do anything, so don't worry about it, okay? But if that is there, you need to do that. So, because we're doing that, we need to set HSP to equal, HSP frac to equal 0, and VSP frac to equal 0, just so we have a fresh slate to start off when we can just set our speeds in a given direction, and we'll move appropriately, okay? So before we go ahead and test this and see the obvious problem with it that we're going to fix, let's add our sliding to this, okay? So where we've got calculate vertical movement here, we've currently got a very simple line, and we're going to make it a bit more complicated. So I'm going to add var grav underscore final, which is going to equal gravity to begin with, okay? So a temporary variable, and that's going to determine what our gravity finally ends up being. It's going to either equal grav or grav wall, depending whether or not we're on a wall, okay? And very similarly, I'm going to have var VSP equal max final to equal VSP max. And then that'll either equal VSP max or it'll equal VSP max underscore wall. Again, depending whether or not we're on the wall. So if on wall, it's not 0, and also VSP is greater than 0, because we don't want to change gravity while we're moving up on the wall. Otherwise, that'd allow us to jump higher just by touching a wall. We just want to move down slower, okay? So we want to make sure that VSP is greater than 0. So if all that is true, then grav final can equal grav wall, and VSP max final can equal VSP max wall. Okay, so we just change those variables around if we need to. And then instead of adding gravity, we add grav final. And under here, I accidentally got rid of the line that clamps our vertical speed. There should be a line here that says VSP equals clamp VSP and VSP max, but it's not here, so it means we had no maximum on our vertical speed, which is fine, but we're just going to add that line back in anyway. So VSP equals clamp, open bracket VSP, so we're going to clamp this value between two values. We've got a very similar line up here with horizontal speed to make sure we don't go over a maximum in either direction. So VSP equals clamp VSP negative VSP underscore max underscore final, VSP max final. Okay, so that's our minimum, negative whatever that is, and that's our maximum, whatever positive that is. Okay, simple as that. Now I'm going to run the game, and we're going to see the problem with our current wall jump. So I can wall jump at the moment, and it all looks pretty much okay, right? And that's me just pressing space when I'm on the wall. But problem is, if I just hold right, or if I just hold into the wall, I can essentially just climb the wall, okay? And you'll find if you are not using any kind of acceleration, so you're not accelerating left and right, it'll look even sillier than this, and you won't even come away from the wall a little bit, okay? You'll just go straight up the wall. You'll probably have seen that in a lot of different wall jump tutorials and things that teach you how to do wall jumps, okay? They don't account for keeping some momentum pushing you away from the wall. This does it a little bit already, because we've got acceleration in our left and right, so we don't just instantly move back in the other direction. We actually have to build a little bit of acceleration in that direction. But we want to kind of kick away from the wall more than this, and currently the only way we can tweak that is by giving us an even stronger kick away from the wall. And our other problem is that every frame we're also clamping our horizontal speed to be the max to max out our max walk speed, rather than whatever our wall jump speed is. Coincidentally, they're the same at the moment. I think they're both 4. So it doesn't really demonstrate that problem as such, but that is also technically a problem. So how do we fix this? How do we give ourselves a system that gives us a bit more control over how our wall jump works, and therefore allows us to tween and tweak, to tweak and tune rather, a bit easier how our wall jump behaves? Well, the first thing I'm going to do is go to the create event and add a new variable down at the bottom here, just where our jump buffer is. Wall jump delay equals 0. Okay, and we'll have another thing as well. Wall jump delay max equals 17. All right, and what we're going to do is have this variable that for 17 frames after we wall jump, we have no control over the player's left and right movement. Okay, so we are forced away. We've given ourselves some momentum, and we're going to let the game sort of carry us away for 17 frames. It's a very specific number. You'll want to tweak this to your specific game. So what we do now is where we calculate our horizontal movement, we're just going to wrap the whole thing in this. In fact, you might, if you're using dir for other things and so on, you maybe want to be careful about what you wrap and what you don't. But for this, we can literally just wrap the entire thing here. So I'm going to type, first of all, wall jump delay equals max wall jump delay -1 or 0. That's going to reduce wall jump delay by 1 every single frame until we hit 0, okay? And then if wall jump is 0, exactly, open curly bracket, and then at the end of your horizontal movement there, close curly bracket before your wall jump stuff as well. Select all this, press tab, just so we've got it nice and clean. And then that's just wrapped all of that. If wall jump delay, there we go, equals 0. That's just wrapped all of that in this value. Okay, so we won't be able to move left and right unless that equals 0. And we want to, it starts at 0, but we also want to make sure it actually gets set to 17 when we do a wall jump, and then starts ticking its way back. So in wall jump, just right at the top, wall jump delay equals not 17, wall jump delay max. Okay, just so it's easier to tweak from our create event. Now if I run the game, we'll see the difference. I'll have to explain a little because you can't see my inputs, but you can see already, like, if I'm going to hold against the wall, so like when I'm jumping against that, I'm just holding the right mouse button down. Okay, you just got to trust that I'm doing that. And then when I press jump, you see how it pushes me much further away from the wall before I'm allowed to move back in the other direction. Okay, and it's still accelerant. Like if I just like jump away from the wall and don't press anything, we have a nice sort of smoother return there. We've got, it's kind of a, it's very quickly how we're like, you know, we sort of like sharply turn around. That's just because our in-air acceleration is quite high. You could tweak that however you wanted. But if I just press jump here now, we can sort of jump up there. It looks a lot better than I did before. And I can't, importantly, just climb a wall just by wall jumping. Okay, maybe you want to be able to do that, in which case, you know, well, you didn't need to do any of this, or, you know, maybe you want to reduce your wall jump delay max, okay, to give you a smaller momentum push away from the wall if you want to be able to climb a wall in that way. But the typical application of a wall jump is more something like this, where you can't just climb any wall just by sort of jumping along one surface. That's generally considered to be wall climbing rather than wall jumping, right? This gives us the actual momentum to kick away from the wall. Also in there, you can see, like if I just go back to the top of here, as I just did, we're sliding down that wall slower, and you can see it like speeds up a bit when we come off the wall at the bottom. Okay, that's everything. Thank you for watching, and thank you to my Patreon supporters for selecting this video topic and for paying for this video to exist in the first place. A huge shout in particular, and in no particular order, to Mark Lintz, Lewis R. Pereira, Doan Techben, Dan, Chris Maher, Gummitainment, James Grumley, Mark Day, Reuben Darlan, Harold Gidry, Matt Coate, Fisk McTaggart, Nick Slavish, Stephen Hagen, Michael Ward, Jason McMillan, Shaunathan, Crispy, Robert Churches, Owen Morgan, Zenan May, Bowser the Dog, TJ, and Patrick Guffey. Thank you all very much.